All right, in this problem we're asked to determine the rate law of a reaction that has two reactants here. So we need to determine the dependence on ammonium ion and the dependence of the rate on NO2 minus, the nitrite ion. To do so, we need to use the concept of isolation of variables. We need to compare trials where everything is the same except for one variable. If, for example, where the trials of NO2 ion are the constant, but we've changed the concentration of NH4. All right, so we have this set up that we're going to compare the rate of reaction of trial 2 to trial 1, and we see that units of K cancel out. And we have set this up so that our concentration of nitrite ion is also going to cancel out. But I'm going to write that out explicitly so that you can see that. All right, so here I've substituted in the values of the concentration that were given to us in the statement of the problem. And we see that 0.10 raised to the n power here is going to cancel out. We need to have these values of concentration to be identical in order to be able to cancel these two factors out. All right, so here I've substituted in the values from the table. This is rate 2 from the table. The initial rate of trial 1 is up here, and I've have the ratio of the concentration of NH4 in trial 2 to trial 1. All right, so we've done the math, and we see that the ratio of the rates is 1 to 2, and the ratio of the concentrations is 1 to 2. So we can tell by inspection that M has to be equal to 1, or in other words, the reaction is first order in NH4+. Actually, we could tell that from inspection simply looking at these values. We see if nitrate concentration remains the same, the NH4 concentration is cut in half, the reaction rate also is cut in half. So we know that there's a direct proportion in concentration of NH4, or in other words, the reaction is first order in NH4+. Now that we determined the reaction order with respect to the ammonium ion, we need to determine it for the nitrite ion. So we're going to compare trials 2 and 3 because we have the same concentration of ammonia, but we have different concentrations of nitrite. So we're going to set up the problem the same way. We're going to compare the rate of trial 3 to that of trial 2. All right, so here we have the setup, rate of 3 to rate of 2. Again, K is going to cancel out, and since the concentration of the ammonium ion is the same in trial 2 as it is in trial 3, these values also are going to cancel out. Okay, so we've input our data from the table, and now we see the rate of 3 to 2 is set up, and the concentration of nitrate ion in trial 3 to trial 2 is set up. So let's take a look at the math. And we have our final result. The ratio of the rates is going to be equal to 1.5, and the ratio of the concentrations is 1.5. So for this equation to be correct, N must be equal to 1. So now we know the values of both M and N. We can write the rate law is that the rate is equal to K times the concentration of the ammonium ion to the first power and nitrite ion to the first power. All right, for part B, we're asked to calculate the rate of the value of the rate constant. We have determined the rate law. It's first order with respect to both ammonium ion and nitrite. So we can use any of the three data sets, plug them into the rate law, and get a value of K. All right, I chose to plug in the data from the first trial, and we're going to turn out this number. When we look at units, we see one of the mole units cancels out. liters cancels out here. So we're going to have units of liters per mole dot seconds. And here we are at our final answer, that K is equal to 3 times 10 to the minus 4 liters per mole dot seconds. The very last problem is to calculate the initial rate when we're given concentrations of the ammonium ion and nitrite ion. And we can do that now that we know the rate law, and we know the value of K. We can determine the initial rate of reaction for any set of conditions. We do have to use some caution to note that we have to stay at this same temperature, because if we change the temperature, we're going to change the value of K. Alright, so we've put in our numbers here. If we look at our units, we see liters cancels here, this mole cancels here, and in our final answer we're going to have units of moles per liter per second. Okay, and our final answer is that the initial rate under these conditions is 6.1 times 10 to the minus 6 moles per liter per second.